Hallo zurück hier auf der Hauptbühne beim digitalen DGNB Jahreskongress. Wir kommen jetzt zu unserem 4. Impuls und damit dem letzten Impuls für heute hier auf der Hauptbühne. Und wir predigen das ja immer wieder als DGNB, dass es wichtig ist, über seinen Tellerrand hinauszublicken. Und im kleinen Netzwerk machen wir das ja immer wieder, indem wir Architekten, Hersteller, Kommunen, Universitäten, Verbände, all diejenigen, die irgendwie daran beteiligt sind am nachhaltigen Bauen, zusammenbringen und auch immer auf Basis der Grundlage des nachhaltigen Bauens dafür motivieren sollen, auch mal andere Perspektiven einzunehmen, um auch zu schauen, was man von anderen lernen kann. Und dieses über den Tellerrand hinausblicken, das versuchen wir gerade hier beim Jahreskongress noch ein bisschen weiterzuführen. Und uns hat es wahnsinnig gefreut, erst überrascht und dann vor allem gefreut, als wir vor gut 3 Monaten angesprochen wurden von der ESA und von anderen Weltraumorganisationen hier auch in Deutschland, die gerne mit uns zusammenarbeiten wollten, die ein Programm aufgelegt haben, wo sich Firmen hier auch in Deutschland mit der Nutzung von unterschiedlichen Technologien, Satellitentechnologien und so weiter, versuchen, ihr Geschäftsmodell auch weiterzuentwickeln, um damit für mehr Nachhaltigkeit im Bauen zu sorgen. Und das hat uns sehr gefreut. Wir hatten da eine erste Veranstaltung auch schon am 12. Januar hier bei uns in der Geschäftsstelle in Stuttgart und haben gesagt, wir würden das gerne noch weitergeben, weil dieser Impuls innovieren, aber mit Blickwinkeln von ganz woanders, das wollten wir gerne weitergeben. Und da hat es uns sehr gefreut, dass wir als 4. Referenten hier heute auf der Hauptbühne Nick Appleyard von der European Space Agency ESA gewinnen konnten. Nick, welcome here to the DGNB Annual Congress 2023. We're very pleased to have you here. At ESA, you're the head of space solutions, and for sure, we'll get a little bit more in detail what this means and what this has to do with building. You have a background in physics, so you studied physics and made your PhD in Cambridge and in Birmingham in the late 80s and the beginning of the 90s, and then have a number of steps. A lot of things had to do with innovation, with digital technologies, and also with sustainability. So for sure, you will focus also on your speech a little bit into where your interest in sustainability comes from. So you'll talk about the idea of co-innovation and how space technology and the building sector can work together. So the stage is yours for the next 25 minutes, and really looking forward to hear what you talk.
Danke, Felix. Entschuldigung, dass ich nicht in Stuttgart sein kann. Ich bin in Spanien heute. Entschuldigung auch, dass mein Deutsch ist schwächlich, and I probably should speak English from this point forward, if you will excuse me. Okay, let me arrange my slide share, and then we can begin. Okay, so thank you again, Felix, for the introduction. And thank you also for the invitation to speak at this meeting. It's a very good fit for us. You will perhaps be surprised to learn from European Space Agency, but I really welcome the opportunity to make a connection with you and with people working in the construction and building industries to see what we can do together in the spirit of co-innovation, and particularly in the spirit of sustainability and construction industry. Now, you may find it surprising to have somebody from European Space Agency talking to you today. The connection may not be immediately obvious to you. I will try to explain. So for those of you who maybe have not studied us and are not so familiar, we are an international agency. We work across 23 countries, all of Western and Central Europe, and really across all of the different areas where the space industry is active and where space has a relevance. So the column on the left there, we're involved in the scientific work and the exploration, the astronauts, the buggies going to Mars, and all of these activities, which maybe are the first things that you think of when you think about space. Is that what I'm here to talk to you about? Well, perhaps a little of this. Also, yes, it is about rockets. It is about mission control. It is about building of spacecraft and satellites. In the second column there, and we support the European space industry in all of their efforts in those areas. But also we're interested in the uses of space. And Felix mentioned my job title around space solutions. Well, what are space solutions? Well, it's if you have a problem and maybe you're looking for a solution to the problem that you have in your working life, in your personal life, then perhaps we can use some of the capabilities of space to solve that problem. And this really is what I want to reach out to you towards. We have a lot of activity which is around safety and around security and around resilience and making sure that the systems and the infrastructures that we all rely on are reliable and we can have trust in them. And this is maybe a theme where we can find some connections, particularly in terms of the stability and reliability of infrastructures. And also, and that column on the right there, the whole area of what we call, from the space point of view, applications, but from everybody else's point of view, satellite services. How are we using space as part of our digital infrastructure to really support services which we rely on throughout our industrial lives? And this really is a topic where I think we have an opportunity to do some things together. So maybe going to invite you to reflect a little bit on the basis of that, whether you're already part of the space economy. Are you already using space in your work and in your life? Because very often it is invisible to us. We don't even realize the role which space and satellite services are playing within our lives. And why did I come to talk to you at the Sustainable Construction Summit? Is it because we're asking you to build things on the moon or on Mars? Well, yes. Okay, we would like to be your friends and have the opportunity to draw upon the expertise which you have already in the industry, so that when we do go and make settlements on the moon, which is coming quite soon, and on Mars, which will follow after that, we have all of the expertise which has been developed in the industries on Earth, the terrestrial industries as we call them in the space community. We have all of that expertise that we can draw on. So we want to make friends with you right now, so that when we need you, we will know you and you will know us. But before that, maybe we can help you with the things that you're doing as you work on the Earth and as you're going about your normal business and in the construction industry here on Earth. We absolutely are already active in this domain and in your industry. You may not even have realized this. I'll give you a few case studies. We can you can see some of the variety of the things that we already do together, and some of the innovations in your supply chains and in your industry where we're already active. So we can play both sides of this. We can play really the construction in space and also construction on the Earth. Let me go through then some of the areas of the supply chain and of the building's life cycle, and show you what I'm talking about. First, before you build anything, I tell you your own business, huh? Before you build anything, you have to know that you're building it on solid ground. I'll give you quite an extreme example here, a project which European Space Agency has sponsored and been involved with, actually a series of projects for structural health monitoring of dams and reservoirs, and particularly monitoring the stability of the land and the footings of the dams to make sure that that ground is strong and solid enough to support the really quite extreme loads which are placed on it. Some of the technologies which we can use in order to help with that, we can actually install radar onto satellites, and using radar we can monitor both the positions and the form of structures. But also with an interference technique using that radar, we can with millimeter accuracy measure movements of the ground, movements of the structures. So we can really look at land stability and ground stability, make sure that the ground that we're building on is secure. So talking then about the stability of structures. This example here is from a bridge in China across the Yellow River, very long suspension bridge, we wanted to be sure then with the UK suppliers offering a service to the Chinese about structural health monitoring of their bridges. To understand then the movement of the bridge, the movement of the ground around the bridge, and particularly how that behaved when it was in service. We used the satellite technique, and I described it before, but perhaps you didn't hear, using interferometry of radar from satellite. So actually reflecting a radar signal from the satellite and measuring the interference signals from that to be where we can measure centimeter, even millimeter accuracy, the movement of the ground at either end of the bridge. But also the sensors which we place onto the bridge itself, we can monitor those using what we call GNSS, so Global Navigation Systems and Services, perhaps more familiar to you as GPS, which is the American version of this. We can use that positioning technology to really understand what is happening with the movement of a structure and make sure that it is safe and reliable in service. So we're using these satellites and these satellite measurements to monitor buildings in service. We also should be very conscious, and I'm aware of the audience and the reason that you're together today, about the environmental impact of what is happening around the construction sites. From space, we can really understand what is happening with habitats. We can understand what is happening with vegetation, with water, and with emissions of pollutants from the construction domain, and make sure that everything is being done in an environmentally responsible way. So there is in the space terminology, we talk about Earth observation. So cameras and sensors and imaging capabilities on board satellites, which are telling us what is happening on the ground and allow us to monitor the sustainability performance of an activity which is happening on the ground, such as a construction activity. So there's a case study here, a project biodiversity net gain, where we're really understanding the vegetation and the variety of the vegetation and making sure that a construction project which was in process was not having an adverse effect on the ground. I just checked the sound is okay now. That's not encouraging. I will continue. So in order to build on Earth as well, we need to make sure that we keep a check on what is happening, as I say. Another case study for you. This is a mining activity, but it could equally well be a construction activity, and the same project looked at factory build-outs. Looking at greenhouse gas emissions and looking at sulfur dioxide and nitrogen dioxide emissions, we can detect all of these things from the infrared signature of the light reflected from the ground. We can see that on the satellites, so we can see what is being emitted from the construction sites as the activity is in progress. You will now be working very much with automated machinery. A lot of that machinery then, which is self-guided, has collision avoidance and has self-driving, driverless capabilities. All of this is being controlled by satellite, particularly if you're away from the terrestrial mobile signals, as we often are when we're working away from city infrastructures. So again, you're relying on satellites for the positioning of those and the guidance of those machines. But we're also, if you are off the grid, you're also relying on satellites in order to be able to receive the data which is coming from things like cameras when you're managing those integrated and automated systems. So these are some of the things where satellites are relevant and useful for construction activities on Earth. Now, I said I wouldn't just talk about what's happening on Earth, but also if you want to build on the moon in the future, then maybe we will want to draw on some of your expertise. So I talk now to the architects in the moon, the architects in the room, and those of you who are involved in buildings design and thinking about the performance of buildings and how one builds a specification for a habitation. We take some of the requirements for that to some quite extreme cases when we're thinking about building in these quite inhospitable environments. But the general character of what we have to do in buildings design, what we have to do in architecture is not so different. We have to think about the stability of the structures. We have to think about the thermal performance. The insulation is a particular importance. We also need to think about radiation shielding. If you're working outside of an atmosphere, you're exposed to the solar wind and to a radiation environment. So there are additional things to worry about there. But also, these are closed systems. So we really need to think about the sustainability and the recycling and circulation of all of the resources inside the habitat. So this is quite a strong design requirement, which if you're going to build off Earth, you need to be thinking about these things. And we have some experience from this. We've been working with space stations since the 1980s, and we really understand now how some of this closed cycle management of resources works. But there's more to do as we start to go off planet. Let me give you then an example of something which the European Space Agency was strongly active in, my own team, just a year or so ago. Really to think, well, what does construction machinery, mining machinery have to achieve in order to be able to be used in this moon environment? What kind of requirements might we place on it to be able to take these machines and use them on the moon? We need to use less water. We can't really be spraying water around and relying on water in a mining or a construction operation. We absolutely need to be working autonomously with a lot of independent control of the machines. So we need this remote operation capability. We need the AI on board and the ability for the machines to make decisions second by second as they go. We need lightweight machines. Anything that we carry to the moon is very expensive. It's very heavy. The mass being carried is going to cost us. So we need those machines to be as light as they possibly can. And we need a power source which is going to come from renewables. It's going to come from solar panels. Now, all of those things, all of those requirements should be recognizable as what you need, or what you in any case need to be doing on Earth in order to improve the sustainability and the efficiency of the operations on Earth. So we challenge people to say, well, look, work in that direction for the vehicles which you're going to use in mining and construction operations on the moon, and they will help you in your mining and construction operations on the Earth anyway, drive you in the direction of efficiency and of sustainability. And this is the win-win that we're looking for. Materials are a major challenge. If we're going to try to build anything off planet, for example, on the moon, we have to work with materials which we find locally. So we have a whole research program at the European Space Agency thinking about how can we take the dust and rock that we find on the moon and turn that into useful material. So first, how can we turn it into construction material? And the answers to that turn out to come with these are silicate materials with some metal ores in them. You can heat treat them, sinter them, build them into more solid materials. You can make composites out of them by introducing binders, or you can get involved in 3D printing and actually make structures out of those. And this is how we're going to make construction materials to use on the moon. We can't carry construction materials with us; they're too heavy. We have to use what we can find on the lunar surface there. So we have a whole research program around that, about materials properties and strengths of materials and the mechanical and thermal and general stability properties of the materials that we can make there. And you see there in the top corner of the slide the ability that we have to actually extract metals from the lunar dust. You start with what is essentially ground up rock, and we've demonstrated in the lab on Earth that we can extract useful metals from that. But materials use and materials recycling and reuse are going to be major concerns as we try to work in our exploration environments. everything has to be very efficient in terms of material use and material reuse and recycling. So again, if we can work with the industry on the ground to improve our techniques around these areas, then that will be useful to us in the long term as we try to move forward with our space exploration efforts. So, for example, we've been doing some work on polymer recycling, trying to take some of what on Earth may be not economic to recycle some of these polymers, and plastics. But if we really if it's a choice between that and bringing in fresh plastics, we would much rather be recycling. And the same with metals. There's an example here of a project where actually taking debris which has fallen from space and shown that we can extract aluminium from it, which then becomes a useful metal for many of the purposes that we have. So that kind of reuse and recycling and retreatment of materials, any advances in that direction which can be made on Earth will become useful to us in the space program. Similarly with biological materials, with foodstuffs and with those kind of waste materials that we generate in the carbon cycle, we need a closed carbon cycle for habitats on the moon. Again, what can we do on the Earth which takes us in that direction towards better recycling and treatment of our wastes? Anything that we can pick up from that technology is going to be useful to us. Let's go back to the Earth for a while then. Back to the construction environment back on Earth, and I'll talk a little bit now about some of the digital services and the digital environment that we need to create here on Earth in order to be efficient in construction. Here's a case study here, which is about communicating. It wasn't actually the construction of the Eiffel Tower, which was this case study, but we use it for illustration. Communicating with information which is being extracted from sensors on the site, and being able to then collate, to draw that information together, input it into our models, input it into our, compare it with our design parameters, and keep a continuous monitoring of what is happening on the construction site as we go. And how do we get that information back from a construction site back to where we're going to do the analysis? If the site is remote, very often a satellite communication connection is a good way to do that. So we have a case study here where we're using the satellite communications as a backhaul, a digital backhaul, in order to collect information about what is happening on the construction site, and use that for problem solving and quality analysis and guiding the construction in real time. And then for the people who are there on the site and wanting to understand their work instructions, to test things, to check things, for rework, for buildings inspection, nice augmented reality application here. Again, communicated through satellite communications, but also with the location of particular work instructions, as described as a virtual post-it, but using that location technology, which is also dependent on the satellites, using that to pin particular pieces of data and information to points on the construction site for the use of those who are actually there in the high visibility jackets, and looking at the work which needs to be done. And all of this information, as we gather together all of this information, is from these digital models, from the sensors which are on site, the Internet of Things deployments which might be on site, from the observations, from the satellite imaging, and from the satellite communications which allow us to link from the construction environment back to our office environment. We can bring all of that together into digital twin models and really build an understanding of what is happening around the construction environment, including its sustainability, performance, and its impact on the surroundings. So, and also for in the case of the Earth observation, we have long time series observations going back over decades of what has happened in various footprint areas on the ground, and we can look back and see how development has proceeded, how urban planning has influenced the location of buildings and the resources around them. So all of this, these are satellite services or satellite information coming together. So, okay, I can draw some of these things together then. In order to do construction on the moon, and indeed later on Mars, we are going to need a whole menu of different services and technical capabilities. Some of which are still in development, and they're really pushing the boundaries of what can be done with materials, particularly recycling and reuse and sourcing of materials, but also what can be done with digital information and automation and remote control of the machinery, and building an understanding of what is happening on site. And this is exactly the same list as what we already work with on Earth in the construction environments there. So we're building our capabilities and our understanding and our technical knowledge on Earth, and we want to make friends with you on behalf of the space industry on Earth by maybe bringing some of this technology to you, so that you can become familiar with it and become expert with some of the space technologies that we have, and we become friends. And then when we need you in a few years from now, we will already be friends, and we'll pick up the phone and say, remember we helped you with that digital model of construction sites 10 years ago. Could you help us with recycling of construction materials now? So this is the co-innovation is going to work in both directions here, and I make no apology for picking up the phone from you 10 years from now and asking for a favor. Now, we're not quite ready to build on the moon. We will be drawing on your expertise when it comes, but it's not too early to start thinking about it, because some of the things, some of the new techniques and technologies that we're going to need will take some years in development, and we would really welcome the opportunity to work with you on some of these things. However, right now, we also are ready to work with you on Earth to try to improve some of the efficiency and the sustainability, performance, and indeed the profitability of the businesses which you have on the Earth. So we can work together on projects with either of those two things in mind right now. Which brings me to then a specific invitation. We are asking now, and this is very timely given why this conference has come together this month. It's perfect timing for us to speak to you, because we're already inviting proposals for space for green construction. And you see our partners there, the Royal Institute of Chartered Surveyors and the European PropTech Association. They've been helping us to make sure that we ask the right question and understand the proposals which are put forward to us from the industry. And the way this works then is a proposal should be made from the industry towards ESA for a project. And particularly in this case, a feasibility study, which may lead on towards a bigger demonstration later. And the challenge that we put to the construction industry is show us, how you can use the space technology, how you can work with the space industry and these satellite data providers and communication providers to do something which is going to reduce emissions and help with waste management wherever you're working on the construction life cycle. So this could be right from the design stage all the way through to beyond life and full life cycle analysis kind of work. Anywhere across that, we would be interested to hear from you what your ideas are from industry, and put those together as a project which maybe will last a year or two's work, and we'll do those things together, and we'll help you with that. Or for those of you who do have this view further into the future and want a position for that, we have at the same time an invitation for proposals for companies who want to get ready to become operating companies on the moon. And this particularly is linked now to a piece of digital infrastructure which we will be building for the moon. We're just starting the process of constructing the spacecraft and the satellites which are going to orbit the moon in order to bring a satellite communication and a location capability on the moon's surface. So we're going to put some satellites around the moon. They will provide that digital infrastructure on the moon's surface for those who are then going to put boots onto the moon and start to build things. And so how would you use that telecom and that positioning capability, link it towards all of the things I've talked about, the automation of machinery, the site surveys, the real-time monitoring of what is happening? What would a project around that look like right now that you could put together, which might use those satellite services? So we invite proposals around both of those two topics right now. This is the parameters of what such a project might look like. We're talking about maybe a 1-year piece of work, costing 250,000 euros. That's our normal ceiling for this first stage study. And we will pay, if you're an SME, we will pay 80% of that. And we ask you to find the remaining 20% from your own private resources, just to show that you're serious about this as a business opportunity. But for the most part, ESA is interested in finding solutions to these challenges, and so we will pay the greater share of the costs. If you're a larger company, a corporate organization, then we would pay 50%, and we'd ask you to pay 50% of your costs in there. But if we're dealing with SMEs, then we will pay 80%. And what we would ask you to do within the course of that year is to really understand what is the viability of a service. What would a service look like? How would it work? What would the technical solution look like? And how would it work as a business? And then to build it towards a prototype stage, a proof of concept stage. We invite many proposals. We will make a selection in a competitive way. And the idea is that this should be something which SMEs are able to engage with us on. So we'd like to really hear from SMEs who have knowledge that we don't already have, and can work with some of the capabilities of the space industry, and we will help you with that. A member of my team would sit with you as part of the project team to guide you through that and help you to link together the different technologies around this. And if the study is heading in a promising direction, then we can go bigger, and we can go bigger, and we can get up to projects in the millions and really start to build and demonstrate things on site and deploy them on site. The timeline on this for the Space for Green Construction call, we're asking for proposals by the end of February. So you have 2 weeks remaining. You need to be moving with a reasonable pace now, but there's enough time to put together a proposal and send it through to us. For the Lunar Economy call, we're just opening it now, so there's some months when we'll still be receiving proposals. And if you want to know the details of that, all of the application processes and maybe some other case studies and examples to work from, you find it all at that website up there, and it's fairly easy to navigate. If you go on the how to apply link under there, you will find those two calls for proposals, and many other calls as well. If you want to get involved or interested in some of the other uses of space in all of the industries of our economy and all of the parts of our life, we are active in many industries, making these similar kind of connections. And if what you would like to do is not an exact fit to one of the ideas, the proposals that I've just made, we'd like to hear from you anyway, and we will assess whatever proposals we receive on their own merits, their merits as businesses, business opportunities, and their merits as technologies. And if we like what we see, and if our friends in your case in the German government, in the Deutsche Zentrum für Luft- und Raumfahrt, DLR, if they like what they see, then we can sponsor the project in the same kind of way as I was describing. So if you'd like to hear more about this, I'll move to the backstage area now, and we can talk some more. And thank you very much for your attention. I heard the sound quality was adequate for this. Thank you very much.
Thanks a lot, Nick, for your impulse, and thanks for the invitation of becoming friends. I'd love to see some of the DGNB member organizations applying to your call, and love to hear to do storytelling later on that it works. Before moving to backstage, one question here on the big stage: do you see that companies already recognize you and also satellite technologies itself, you as a partner, or do they believe that satellite technologies or services are some sort of a given thing?
The satellite technology, the satellite services are there already. We've been launching satellites since the 1980s, which provide these service capabilities of telecommunications and of observation and monitoring of the Earth. It's there. The space industry has taken care of that. Really, I think the question now to all of the other industries of the economy is how can you use that existing technology as part of the digital infrastructure and the digital environment which you're building, because sometimes you rely on a web service, a mobile service, it's incomplete. There are things that you can't do working with the telecom providers on the Earth. This is supplementary to that. Sometimes it is the only choice that you have.